Now, what do we do if we don't have an estimate for p hat? If we don't have an estimate for the population? All right, this is just a separate formula. It basically takes that p hat being 50-50. If we had two of them and multiplied them together, 0.5 times 0.5 is 0.25 or 1/4. All right, so this actually kind of splits the difference between having a p hat of 50 and a q hat of 0.5. Sorry, 0.5 and 0.5 for those two. That's what we do when we have an estimate. But overall, we write the formula this way. You can write that as 0.25 if you wanted, or as 1/4. Or if you want to have it as a single fraction, you could write it like this. It's the z-score squared divided by 4 times e. So those both have to be, e squared, have to be multiplied in the denominator there. All right, so a different formula when we don't have the estimate for p hat. This is what we do. Let's go ahead and do an example. A political candidate has asked you to conduct a poll to determine what percentage of people support her. The candidate only wants a 4% margin of error. All right, they only want a 4% margin of error. That's my error bound being 0.04 because it is the decimal version of that percentage. At a 99% confidence interval or confidence level, what is the sample size needed? So they didn't give us an estimate anywhere in here. Again, I mean, this is the example following not having an estimate, so that makes sense. But if you were looking at a different problem, if you were looking at your homework, all right, you're looking for the number of successes and the number of failures to be able to make, or sorry, number of successes and number of trials to be able to make that p hat or be given that p hat like we were in the last one. Here, we don't have either of those things, so we know we don't have an estimate. All right, we have the error bound, we have the confidence level. Remember, with that confidence level comes our z-score, alpha for 0.99. This is one we actually haven't done yet. 0.99 would mean alpha was 0.01, very small, which means alpha over 2 is 0.005. It's a very, very small value. So we go, I'll show it, kind of in a quick picture here. We go to our normal distribution with a mean of 0 and a standard deviation of 1. We make sure we're shaded to the left. It's going to be really tiny. And we don't put in this value. We put in this value over here. All right, and when we do that, we'll have the negative version of this. All right, so I'm going to only write the positive one down, but it would show up negative if you went to actually put this in your calculator right now, but we want the positive version. The z-score for 0.005 is going to be 2.5758. All right, that's the z-score. So now we have z, we have the error, and we can actually use our formula to find the sample size. N was equal to the z-score squared divided by 4 times the error bound squared. 2.5758 squared divided by 4 times 0.04 squared. Again, pause, get out your scientific or whatever you would be using on the exam. Type this in and see if you do indeed get 1036.6790. This isn't my answer. I need a whole number for a sample size. I can't interview 1036.67 of a person or 68 of a person. So instead, I need to interview 1,037 people. We need a sample size of 1,037 for a 4% margin of error. Once you've practiced this by hand a few times, or if you just want to check your answers before using doing the online homework, right? Again, you do need to know how to do this by hand. I can't emphasize that enough times. If I go to my online calculator here, we have no estimate for P. So now we check that box. We still had an error bound of 0.04. That was the same as the last example. We want a confidence level of 0.99 this time. And you see that 1,037 right there.